So today, in lesson 2.4, we're going to talk about applying properties of equality to justify steps. We're going to learn a couple new theorems, and we'll apply the properties. Yes, you can borrow that. Okay, properties of equality. I am not going to pretend that every one of these are life and death that you remember. But there's a few that I've starred here that are very important. We're going to write them all down. We're going to talk about all of them, but we're going to make sure we learn these few really well because they're going to be used over and over again throughout this course. Okay? The others you use all the time. It's not a big deal. Okay, properties of equality. You learn these in algebra. The addition property of equality. It says if A is equal to B, then A plus C is equal to B plus C. In other words, if you're solving the equation, you want to add 5 to one side, what do you have to do to the other? Add 5. That's correct. Addition property of equality. All these properties in the book would say of equality on them. I just put that up here at the top, of equality. So the subtraction property of equality, what do you think that's going to say? Awesome. Perfect. If A is equal to B, then A minus C equals B minus C. What do you think the multiplication property says?
If A equals B, then A times C equals B times C.
Awesome. If A is equal to B, then A times C is equal to B times C. Perfect. I don't know why I couldn't get my periods that I use for multiplication symbols to stay underneath that box, but anyway, they're already in there for you. Save you the work of typing or putting those big black dots in there. Just thinking about you. And division property. That's right. If A is equal to B, then A over C is equal to B over C. Reflexive property seems so obvious, so simple, so crazy that I would start because you'll look at it and think, what is important about this? But believe me, we will use reflexive property when we get into Unit 4 and we're we're writing proofs. We have to use reflexive property all the time. Okay? And it is very simple. A is equal to A. A is equal to A. Emily, do you have something in front of my desk? A is equal to A. I don't know how to emphasize how important this is when we get into Unit 4. Other than just trust me, we'll use it over and over and over again. Right now, it's not such a big deal. Really, probably, other than the fact we're talking about all these other properties today, it probably is a little bit out of place today. But when we get to Unit 4, we'll use it. And so, star it. Remember, at some point, I'm going to say, hey, remember back I said this is really important? We're doing all those other properties. Reflexive property. Okay? Symmetric. If A is equal to B, then B is equal to A. Have you ever applied the symmetric property before? Yeah, you have, Cody, you're right. And it's okay that you've forgotten, but you probably saw it something like this. I'll just write to the side here. You probably had something like 24 is equal to x minus 3. And when you're first learning to solve something like this, you probably thought, you know what, I would rather turn this over and have my x on the left side. And so we rewrote it as x minus 3 equals 24. Have you ever done that before? Taken the equation, flipped it over. Okay? That's symmetric. It says if the left side is equal to the right side, then we can flip it over and say the right side is equal to the left side. Okay? Symmetric property. Transitive property. Have you heard that before? Yeah, when did I talk about transitive property? Not very long ago. Harley, join us. When did I talk about the transitive property? What law were we talking about? I said some books call it the law of transitivity. And it makes sense because it's just like the transitive property. What law were we talking about when I said that? Law of syllogism. I heard someone say it starts with an S. When you're not really good at saying that word, it's kind of hard to remember. But it's the law of syllogism. It says what? What did the law of syllogism say? I'll help you out. If P then Q, and if Q then R are true, then if P then R is true. Okay? Well, transitive property. If P then Q and if Q then R are true, then if P then R is true. Transitive property, sorry, I gotta have a pointer here. Transitive property says if A is equal to B and B is equal to C, then A is equal to C.
Oh my God.
If Cody has the same amount of money in his pocket as Amelia, and if Amelia has the same amount of money as Kaylee, then Cody has the same amount of money as Kaylee in their pockets. Okay? Amelia, do you have any money in your pocket? Do you have any money in your pocket? They're equal then, right? You have any money in your pocket? There we go. I picked the right three. Do you see how the transitive property looks very similar to the law of syllogism? Does anybody see that? Raise your hand if you see how they're similar. Okay, good. We said, if I write it down, P implies Q, and Q implies R, then P implies R, right? That was the law of syllogism right there. And above it is the law of transitive, it's the transitive property. And so one textbook we had not long ago, I shouldn't say that, we've had these books a long time, but the textbooks before we got these called this, instead of the law of syllogism, and called that the law of transitivity because it's so very similar to the transitive property. It makes sense. Okay? Good. Substitution property. Probably never used that before, have you? It says that if A is equal to B, then B can replace A in any expression. Think you've ever used that before? Paul's saying probably last year. Let me ask you this. Have you ever been given a problem that says evaluate? When x equals 4, and you have 3x plus 2.
Yep.
Okay, what was the first step you did when you had to evaluate that?
Replace X with 4.
You replaced the x with a 4. You substituted, didn't you? Substitution property. If you know two quantities are equal, it might be a variable equal to a number. It might be some different forms of the number, okay? But when we know they're equal, we can substitute them in. Substitution. Okay? And the last property we have here is the distributive property. Remember that? How's that one go?
Yeah, just distribute to both sides.
Okay? So A times the quantity of B plus C is equal to A times B plus A times C. And then if they have a minus sign inside, it would be the same thing, only minus. So that I wrote them both down. A times quantity B minus C is equal to A times B minus A times C. Distributive property. Any questions on any of these properties? Okay. Turn in the page then. Angle addition postulate. Angle addition postulate. We have a picture of an angle. Has angle ABD and angle ABC on it. And angle DBC. What kind of an angle is angle ABC? It's a straight line, but it's also a straight angle. Okay? And it has a measure of 180 degrees. Okay? So a line has a measure, an angle measure of 180 degrees. And so our property, our angle addition postulate says, if D is in the interior of angle ABC, then the measure, the M stands for measure of angle ABD, plus the measure of angle DBC is equal to the measure of angle ABC. I'm going to pause while you copy that, and then we'll make sure you understand what it's saying. You may not be quite finished copying, but you'll have some time here. If we look at angle ABC, I'm sorry, ABD, misspoke. Angle ABD is that angle there, right? And then angle DBC is this angle here. What this property is saying is if I add these two angles together, I'm going to get the big angle. If I add them together, I'll get the big angle. We use this all the time. Okay? We use it all the time. You want to get very comfortable with this. And having said that, I realize we don't have any examples on this, so we'll make one up real quick before we quit today. Okay? I'm hoping that our notes will take most of the period because I plan to give you all of tomorrow except for what time you take on the quiz to work on your homework from the day. Okay? And I don't plan to give you more. I'm just going to give you time to work on today's. But the reason I say I'm hoping it takes most of the period is because I want you to try some things in your group. I want you to talk about some things, and I want to have some good discussion going on about what we're talking about. The angle addition postulate. We add up two angles that are adjacent. Adjacent means they're next to each other. They have the same vertex. In this case, they share the same vertex B, and they have a common ray. In this case, ray BD. So these two angles are next to each other. They're sharing the same side. If I add them up, I'll get the big angle. Okay? That is the angle addition postulate. Anytime you see a picture and you make that first statement, the reason you know that's true is because of this postulate. So if you're asked to write a simple proof, and you start out by saying that two x plus 3 plus 3x minus 5 is equal to 180. Remember we said this angle's how big? We just said it's how big? 180, right? A line has a measure of 180. And so that angle is 180. So if we said 2x minus 3 plus 3x minus 5, I'm sorry, plus 3, I misspoke. Plus 3, and 3x minus 5 is equal to 180. The reason I know that's true is the angle addition postulate. Okay? The angle addition postulate. So whenever you start out by knowing, hey, that's true, it's because of this postulate. So if you're asked to justify your steps, if you're asked to write a simple proof, okay, that's what you write down anytime you make a statement like that. And you'll raise your hand and you say, I don't know what to write here. And I'm going to say, well, what do you have in front of you? And you'll say angles. I'll say, well, what are you doing with those angles? Well, I'm adding them. So what property or what postulate allows us to add angles? The angle addition postulate. Okay? All right. Well, I'm not going to go ahead and solve that. It might work out well, but it may not work out too well since I just threw some numbers up there and I wasn't worried about them. But that's the major setup. Okay? Segment addition postulate looks very similar, except we're talking about what? Segments. The segment addition postulate says if 3 points, A, B, and C, are collinear, meaning all on the same line. What does collinear mean? All on the same line. And B is between A and C. That's B is the middle letter only is important in this rule because we've got this set up as B is in the middle. Okay? Then that means AB, the distance from A to B, plus BC, which means the distance from B to C, is equal to AC, or the distance from A to C. Okay, I'll pause. You can copy that down. Do you have any questions on what the segment addition postulate is saying? Okay, let's try it. So the segment addition postulate says that since A, B, and C are all on the same line, and since B is between A and C, then the distance from A to B plus the distance from B to C is equal to the distance from A to C. Okay? So, what statement can I write? 2x minus 1 plus
4x plus 2 is equal to C? No.
is equal to 25. Because we were told right here that AC is 25. Now, if I was asked to justify this step, what would be my reasoning? How do I know this statement is true? Segment addition postulate. So if I had to justify my step, right here I would write, I'll write y's up here. Segment addition postulate. Segment addition postulate. Because I see in the picture that A, B, and C are in the same line and B is in between. So that means this distance plus this distance will equal this distance. Okay? Segment addition postulate. So, what's my next step here? I want to solve this for x. What's my next step? Add combine like terms. Very good. So 2x plus 4x is 6x. Minus 1 plus 2 is plus 1 equals 25. Now, what am I going to write over there for the y's? How did I know that was true? Or what did I do? Lauren, what did you tell me to do? Combine like terms. I can write that down there. I could write, I added. Okay? I could write, I simplified. Okay? I simplified. You can just write that down. Oops, I forgot something, didn't I? I forgot the 1. 6x plus 1. Hopefully you didn't forget that. Now, what am I going to do next, Neat Nick? Solve this equation for x. What am I going to do next?
Divide the 6. Yes, because the 6 is different x, you gotta get rid of 6.
Remember, when you're solving, it's undoing, right? So it undoes the order of operations. If you were simplifying, you would do multiply before add. But when you're solving, you would undo, so you go opposite. What would you do first? Minus 1 from both sides. And so you get the statement 6x equals 24. So what do I write over here? What did I do here to get this? And so what do I write for how I did that? Why is it okay to do that? What fills in the why? Why am I allowed to do that? Which one of these applies?
Subtraction property.
The subtraction property, right? Says if I have two statements equal, I can subtract C from both sides. Okay? So that means over here I write subtraction property. Okay? Subtraction property. What's the last step of solving this, Brandon?
Divide by 6 both sides.
Divide both sides by 6, and so x is equal to 4, and what goes here as to why that I did that? Paul?
The division property.
The division property. I divided both sides, so I used division property. Okay? The properties, addition property, subtraction property, division property, multiplication property, those are when you're doing them to both sides. Okay? If all you did was add it in a problem on one side and combine like terms, you can write addition, but don't write the addition property. You can say I added. Up here, I could say I added these. That's okay. But don't say addition property here because we didn't add the same number to both sides, and that's what the addition property says. Any questions on that? All right. I want you to try this one now. I do want to talk about the y's. Okay? So you can do the best you can on them, and then I'll combine with you, and we'll do them together.
Hey,
Looks like most of you are done with this side of it, and you're working on the y's, so let's come together real quick. What was our first statement here? What did I write first? 4x minus 2 plus 3x plus 5 equals 24. Why did I know that was true? Segment addition postulate. Because there's segments in our picture, we're adding them up to get the big one. Segment addition postulate. Okay? Step 2, what do we do to both sides?
add
Nothing, right? So what do we do first? We
like terms.
added like terms. 4x plus 3x is 7x minus 2 plus 5 is plus 3 equals 24. We simplified, or we added, or we combined like terms. Any of those phrases would be okay. Okay? What do we do next? Minus 3 from both sides. We got 7x is equal to 21. What reason did we do what we did? Subtraction property. And then the last step, divide by 7, we get 3. And so what is this? Division property. Very good. Okay, now, this next statement, in your group, talk about some misconceptions about the location of point B. What mistakes might some people make? Meaning, had we not just done one almost identical to this, and they looked at this picture right here, and this is off to the side, and maybe they overlook it. Talking to your group about what misconceptions they might have made about the location of point B. And then what mistakes might they make in trying to solve. Okay? I'm going to pause this. I want to give you about 2 minutes. Okay. Join me again. In your group, talk about some misconceptions. What do you think some misconceptions were about the location of B? Nikki?
You might think it's the scale.
They might think it's the scale. I'm just going to say might think to scale. Okay? What else might they think? Paul?
It's in the wrong place.
It's in the wrong place. Jacob?
The line segments are the same because point B is right in the middle.
B is in middle. Segments are same. Okay? Any others? Some of you had more things written down. You had exactly these. Okay? Let's move on to the second part. What mistakes might some people make then in solving this? What mistakes might they make in solving?
They could have done the problem wrong.
They could have done the problem. Okay. Exactly. You're exactly right. Can you help me think of how they might have done it wrong?
They could have subtracted or something like that.
Oh, you just think in the process they had it set up, they might have made a mistake and so. Okay. So you're saying used wrong properties. Meaning they use subtraction property, they should have been using addition property or something like that. Okay?
They wrote the equation wrong.
Okay, used wrong equation. How do you think they got the wrong equation?
They didn't know what AC was.
Didn't know what AC was? Okay. Did I see another hand up over here? Jacob?
They could have solved to try and make X to make both the lines the same.
They could have said 4x minus 2 equals 3x plus 5, was it? They could have said that, right? That's the wrong one, isn't it? Okay. Any other thoughts?
Sorry.
Okay. The reason I threw this in here is because every year I put questions like this on the test. and every year I have too many students making mistakes on it. Okay? So this year I've approached this a little differently. I wanted you to brainstorm a little bit so you could see where future mistakes might come from. If we go back to the original picture, I agree. Where does it look like B is at? In the middle. When we think of it in the middle, we think the left side's equal to the right side, don't we?
Yeah.
Yeah.
We end up writing statements like this, don't we?
Yes.
Okay? Let's go back up here again. Anywhere in here, did it tell me that the distance from A to B is equal to the distance from B to C? No, they did not. If they don't tell you those things, you cannot assume it's true. Okay? You cannot assume measurements. That's one of the rules of geometry. You might want to write it down underneath here. Right down here. You cannot assume measurements are what they look like. Okay? You cannot make those assumptions. If you do, you'll be wrong. Okay? You'll be wrong. You'll get the wrong answer. You'll be setting up the wrong equation. And I'll come by and you'll be saying, I don't know what's going on here. I made a mistake. And I said, yes, you did. I'll say, you got the wrong setup. And I'll turn around and walk away. On a test, I'll tell you that much. You can ask me, hey, did I set this up right? And I'll look at it and say, yes, you did, or no, you did not. If you follow it up with, well, I don't get it, how do I do it? Well, of course, then it's a test, right? So I'm not going to help you with that. But I will be glad to tell you if you've set it up correctly. You cannot assume measurements are equal. The way we did this problem right here, we're not assuming anything. We're told this represents this distance. We're told this represents this distance. We're told this here represents this big distance. We're not making assumptions. They told me those things. And because I have a property that says, or postulate says this distance plus this distance equals the whole distance, then that allowed me to write this statement. No assumptions there. Okay, it's all fact based on the picture they gave me. Okay? What I can't assume, what I cannot do, is assume that this is the same as this just because they look to be the same in the picture. If I have a triangle that looks like this, what kind of triangle is that?
Or right triangle.
Wrong. It doesn't tell me it's a right angle, does it? So I cannot assume that it's a right angle. You're right, it looks like a right triangle. But I can't make that assumption. If they don't do something like this, which means those two segments are perpendicular, which means it's a right angle. If they don't do that in there, then I cannot say that's a right triangle. All I know is it's a triangle. Okay? And if I have one that looks like this, I can't assume that's an isosceles triangle just because those two longer sides look the same. I cannot assume that because those are measurements, aren't they? If I say they're the same, I'm saying they're the same length. That's a measurement. If I'm saying this is a right triangle, I'm saying this is a 90-degree angle. That's a measurement. I cannot assume measurements, okay, based on pictures. You can assume that points on the line are really on the line. You can assume those things. A segment connects 2 points. Okay, you can assume that that's really true. That's based on the picture. But what the measurements are, the length of the segments, the angles of the measure, or the measures of the angles, you can't make those assumptions. Jacob?
You need SAS or ASS or one other one now.
No, we're not into that yet. We'll get there. You're saying some good things, but right now we're just talking in general about when we look at a picture, what it's okay to assume in that picture and what it's not. Okay? So the most common mistake in this problem is people want to call B the midpoint, and they never told me B was the midpoint. They never told me these distances were equal, so I can't do that. Okay? Any questions on that now? All right. Last one here. I would like you to justify each of these steps. There's 5 steps to simplifying this. So do first step, and then tell me why. Do the next step, and then tell me why. Justify means the whys. Why did I know that was true? What property, what postulate, what theorem, what definition allows me to say that? In your case, they're just going to be properties and postulates. Okay? So I'm going to pause this. I want you to try that in your group, and then we'll come back together real quick in 2 minutes and 5 seconds. Go. Just real quick, what's the first thing I'm going to do here? I'm going to do this, right? So when I rewrite it down here, I'm going to write 3x minus 6 plus 5 equals 13x minus 11. What did I do? Distributed property, right? I did the distributive property. Now, I don't want to show the work on this next line. I want to show the result after I did it. So, if you're doing the work in here, do it in this little space here. And then down here, show what you get after you did that. And then tell me here why you did what you did. Okay? So the first step is done there. Let's go back and try it again. We've got a minute and a half. All right, I know you're not all done yet, but if I waited for everybody to be done, sometimes it would take way too long. So we're going to do this together now. What did we do next here? Sorry to call you by your last name. And they had a raw at the end instead of an Ariana. Instead of call you Sandra. Sorry. Ariana, tell me, please, what did you do next, this next line? Oh, you did? Okay.
And then I got x minus 6 plus 5 equals 31.
Now, well, listen. Remember, there's always more than one way of approaching it. So she didn't do it the way some other people did it. That doesn't make it wrong. We could do this. She subtracted 3x from both sides, got minus 6 plus 5 equals 10x minus 11. So what property did she use? Subtraction property. She subtracted 3x from both sides. Oops, there. Subtraction property, not property, subtraction. Okay? Now, what might I do next if I used her first step? I would simplify, and what would I get? Negative 1 equals 10x minus 11, and you said the reason was? Simplify. Okay? What would I do next, Neat Nick?
You would add the 11.
Add 11 to both sides. 10 equals 10x, and what's my rule over there? Addition property. Okay, Amelia, what would I do next? Divide by 10, I'd get x equals 1, right? When you divide a number by itself, you get 1, right? 10 goes into 10 one time, right? And so that is what property? Division property. Now, someone else might have done simplifying first. How many of you did that first? Okay? That's usually what we teach because we want to make it simpler before we get into switching sides. But that doesn't make this wrong. Okay? It doesn't make this wrong at all. You can do them in any order you want with some exceptions. Okay? If you divide first, then you've got to be really careful because you have to divide everything and then it's going to get messy. So division you wouldn't want to do until last, but the others you can mix them all up. Okay? Any questions on that? All right. Then, remember, the rest of today and all of tomorrow you'll have to work on this with the exception of the moment tomorrow when you're taking your quiz. Your quiz will not have any of this material in it. I believe it's only 2.1 and 2.2, but there could be a couple things from 2.3 in there. Okay?